Hi, boys and girls. As promised, this shout out goes to Sierra, who needs to keep up with her persistence in trying to help others. Thank you. You've got good determination. Don't get frustrated. Thank you for your help. So, we're going to keep talking about slope. And today, we are talking about slope and the triangles that we make. Okay, so right now, and then we're going to talk about it more tomorrow about these similar triangles. So let's take a look at it. All right, so hopefully at some point you have talked about similar figures or similar triangles. So these two triangles here are similar. And what that means is the ratio of the corresponding side lengths is equal. So we have this smaller triangle and then this bigger triangle. Let's think about this in terms of slope. Is the 3 the rise or the run? Good, the 3 is the rise, and then the 4 would be the run. So if we were to find the slope of that smaller triangle, the slope would be 3 over 4. Let's look at the bigger triangle. If we were to find the rise and the run, so the 6 is the rise, the 8 is the run, so we have our slope. So we have 6 over 8. What do we always need to do? We always need to simplify or reduce. So what does 6 over 8 simplify to? Divide top and bottom by 2, numerator and denominator by 2, and we get 3 over 4. Well, hey, wait a second. 3 over 4 and 3 over 4, the slopes are the same. So when there's two similar triangles and they're on the same line, I'm going to show you on the next slide what I mean by on the same line. The similar triangles have the same slope. And this slanted slide, we're going to learn later in the year, is called the hypotenuse. So the slope of that hypotenuse is the same. So similar triangles is the ratio of the corresponding side lengths is the same. And hey, that's how we find slope. We take the ratio of the rise and the run. So similar triangles is it's similar to finding the slope. Let's look at this on a graph now. So I have these two triangles here. See how the hypotenuse, the slanted slide, forms one long straight line. Okay? You wouldn't want to say that we have this triangle here, and that's going to be similar because that doesn't lie on the same line. So the triangles have to be forming that same line. Okay, so let's find the slope between Q and R here. So we define our rise is 1 and our run is 2. So slope between Q and R is 1 over 2. Now let's do over here our rise from R to S goes 1, 2, 3. And our run is 1, 2, 3, 4, 5, 6. So the slope between R and S is 3 over 6. And what does that reduce to? That reduces to 1/2. Okay, let's say we're now going to find the slope from Q all the way to S. Okay, and the reason why this is helpful is because sometimes you don't have all of the points on your line. So what if they only give you the points Q and S? Well, if we find the slope here, we go up 1, 2, 3, 4. So the rise here is 4. The run, 1, 2, 3, 4, 5, 6, 7, 8, is 8. Our slope is 4 over 8, and what does that reduce to? 1/2. Between any 2 points on that same line, the slope is the same, and that's because we form these similar triangles. And similar triangles, the ratio of the two side lengths, which is our slope, ratio of rise to run, is always going to be equal, always going to be the same. So you can find the slope between any 2 points on that line. We can find the slope between Q here, and we can make another point here, and that's going to be 1/2. We could find the slope here from here to here, and that's going to be 1/2. We can go from all the way over here to all the way over here, and the slope will still reduce to 1/2. So here's your question. So we've got these two triangles here. Their hypotenuse forms the same line. Here's the side length. The smaller one, it's 6 and 10. The bigger triangle is x and 15. So the rise here is 6, the run is 10. The rise here is x, the run is 15. Take a guess, or not really more than a guess, an educated guess. So if we were to find the slope of the smaller triangle here, rise to run is 6 to 10. That would reduce, divide both sides by 2 to 3/5. What does x need to be so that we would have the same slope here with this hypotenuse? What's the slope between these points here? Remember, it's a similar triangle, so we need to reduce to that same 3/5. So see if you can find the value of x, and you can write it down. You can add it in your comments, or you can submit it, is what I'm trying to say. And we're going to do a little bit more of this tomorrow. Hopefully the rain holds off and we can go outside and do something measuring outside. Okay, have a good night. See ya.